I want to make 3 videos now on the subject of integration by parts. There'll be 15 examples altogether in 3 units, which means there'll be 5 examples in each unit. And the first one I've labeled as I equals the integral of e to the x times sine x dx. Well, using the rule for integration by parts, which I assume you know, it'll be the first, which is e to the x, multiplied by the integral of the second, which will be minus cos x, and then minus the integral of the first one differentiated, which will still be e to the x, and then the sine x integrated, which is minus cos x. The next line is just tidying up the first. So I've written that out as minus e to the x cos x plus the integral of e to the x cos x dx. And then continuing, copy down the minus e to the x cos x, and now perform the integration for the second time by using parts again. And this will be the first, which is e to the x, times the integral of the second, which will be sine x, and then minus the integral of e to the x differentiated, which is just e to the x, times the second integrated, which will be sine x dx. Now, should notice that this last integral is the very integral that we are trying to find. And so what we'll have then is twice the integral we want, equals e to the x times sine x minus cos x, and so I will equal 1/2 e to the x times sine x minus cos x, and plus the obligatory constant at the end. So that deals with the first question. On the second one, we just want to integrate log n of x. And we write that as log n of x times 1. Bearing in mind that 1 is still a function of x, being equal to x to the power 0. So carrying out the integration by parts again, we'll have the first, which is log n of x, times x, which is the integral of 1, and then minus the integral of the first differentiated, which will be 1 over x, times the second integrated, which is x. The x's now cancel out. So on the next line, we'll have x log n of x minus the integral of 1 dx, which will simply be x log n of x minus x. And then simplifying that, there'll be x log n of x minus 1 plus the obligatory constant c. Moving on to question 3, we do that in a similar kind of way. That's integral of sine inverse x dx, which we'll write as sine inverse x times 1 dx, and then carry out the integration by parts. So that will be the first, which is sine inverse x, times the integral of the second, which is x, minus the integral of the sine inverse x differentiated, which is 1 over the square root of 1 minus x squared, and the 1 integrated, which is x dx. Now, in that integral there, we'll let u equal 1 minus x squared. So du will be minus 2x dx. And the integral, which I've labeled as a, will transform to minus 1/2 integral of du over u to the half, which is minus 1/2 integral of u to the minus half du, which is minus 1/2 u to the plus half divided by 1/2. The halves cancel out, leaving us with minus u to the half, which is minus square root 1 minus x squared. And so our final result is x sine inverse x minus minus square root 1 minus x squared. In other words, it'll be x sine inverse x plus square root 1 minus x squared plus the obligatory constant c. Moving on to question number 4, we'll have the integral of x squared e to the x dx. This one is quite straightforward, really. it'll be the first, which is x squared, times the integral of the second, which is e to the x, minus the integral of the x squared differentiated, which will be 2x, times e to the x integrated, which will be e to the x still. And then on the next line, we'll have x squared e to the x minus 2. I've taken the 2 outside, and then bracket, and then we carry out the integration. So that'll be the first, which is x, times e to the x integrated, which is e to the x, minus the integral of the x differentiated, which is 1, times e to the x integrated, which is still e to the x. And so what we end up with is x squared e to the x minus 2x e to the x plus 2 e to the x. And just tidying that up a little bit, we'll take the e to the x outside. So that'll be e to the x bracket x squared minus 2x plus 2 plus the obligatory constant c. And just one more, this unit will be the integral of x tan squared of x dx. So that'll be the first, which is x times tan squared of x integrated, which is tan x minus x, and then minus the integral of the first differentiated, which is 1, times the tan squared integrated, which is tan x minus x, and then dx. So multiplying out, we got x tan x minus x squared plus, now the integral of minus tan x is plus log n cos x, and then you have minus minus, which is a plus, and the integral of x will be x squared over 2. And so finally we have x tan of x, x times tan of x, plus log n cos x, minus half x squared, plus the obligatory constant c. So that brings us to the end of the first unit. There'll be 10 more exercise examples given in 2 separate units. Thank you for listening.